Yeah, g'day, Mark here, and welcome back to my channel. Now, if you've been watching closely, you'd know that I've been installing a DRO, the DrDro system, onto my surface grinder. I'm going to get it finished today. Adding the DRO's got me thinking about accuracy, and specifically, does a DRO increase the accuracy of your machined parts? Let's have a look. Right, now before we get started on today's video, I do have a couple of public service announcements to make. Now I've got a special shop visitor this week, so stick around to the end to meet David. YouTube's continual AI monitoring has pointed out that there's been a couple of people who have watched videos but have skipped over some not so interesting bits to get to the bits with sparks and crashes. Mike in Sydney, I'm looking at you for example. So to address the issue of people slacking off or riffraff sneaking into the channel, it looks like I'm going to have to implement a requalification exam. So have a good think. If you've been slacking off on watching RotarySMP this year, you're going to have to go back and watch all the videos closely to be able to pass the exam to qualify for viewership next year. My second public service announcement is, are you guys watching Haxby's Shed? Now, Paul's had a great channel for a long time, but YouTube only showed it to me quite recently when he got his Clarkson tool and cutter grinder, and he's been working on trying to fix some of the issues with that. I'd really recommend you watch the whole series, but I'd like to specifically bring your attention to his last week's video where he talked about his first ever car, which was a Mini, which he did quite a substantial change in the entire body and stuff on. So after this video, I want you all to troop over to Haxby's Shed, watch all of his Clarkson cutter grinder videos, and the one about the Mini, make his channel blow up. Now my last DRO video ended with all the brackets made and the housing done and everything, and I just need to paint it and then reinstall everything. But it's winter, so paint's going to take a while to dry. So in the meantime, you got time to go back and look at all those videos. Now since I'm curious to see whether having a DRO assists with accuracy or not, I'm going to need something to grind to compare. Something like a block of steel. However, I don't want to just waste my time grinding a useless block of steel. And since so far I've held my dressing diamond in a vise, and that seems like a pretty lame way of doing it, and this block of steel seems just about the right height to hold my dressing diamond. And in fact, to hold it at two different levels, and that could be quite handy. By the way, this steel, I think it's a Burla steel, K30 something. I'm pretty sure it's a pretty highly alloyed steel used for making dies, punches, something along those lines. Now trying to see the difference in workflow that the DRO makes is a big part of this. A second thing is I need to learn and practice how to size pieces of metal to an accurate dimension, accurately square and nice and parallel, and this seems like just the right part for that. The width of the block should already be parallel. I'll just check, make sure my micrometer is set. First side I want to make accurate. Let's see, I think this comes out at about 44. So I don't think I'll bother machining that side. Well, let's take a look at perpendicularity. When my mate Luke loaded up the surface grinder to send it to me, he also packaged in a few of these precision ground blocks. This came from an auction, I think. It was obviously a company that had done a lot of machine restoration, and he got a bunch of straight edges and stuff off them. So let me just clean this up. Right, let's just dress that block a little, because I think there's a few little burrs on this side. Oh yeah, definitely. This lovely little Eclipse gauge was given to me by my dad. The good thing is it's got a round tip on one end, so you can use it as a squareness comparator. Well, what about the other end? Oh wow, nice. Let me just lay that down. I'd say it's very unlikely that that is anything other than beautifully precise. Wow, this sucks down quite nicely. It really takes quite a bit of force to lift it directly, but it slides beautifully. Before I can start playing with the grinder, I need a couple of holes in this. So the idea being a hole to mount it here, and a hole to mount it here, and just set screws to lock it to both directions. Now, because I'm going to be mounting a dressing diamond, I don't want it pointing straight up. I want it a few degrees off so that you can keep the diamond wearing slightly differently just by rotating it. And they'll just be secured with some set screws, but I'll put them in after I'm finished the grinding. So what's my target here? I'm going to grind these two surfaces to exactly 44.000, and I'm going to do these ones without using the DRO. If I find they're not going to clean up, then I can still define something new for them. I'm getting a pretty rough surface finish with that, but I think I'll concentrate more on dimensions on this job rather than chasing surface finish with different wheels. So now let's go and take this over to the surface plate and see how square those edges are, which is an indication of how square my vise is. So it looks like I'm only about 2/10,000th of an inch off square there. What does the other side look like? So this side I'm about 1/10,000th under, and this side I'm about 1/10,000th over. Now I must say that actually amazes me for that vise. That's better than I could possibly have imagined it being. So how much material do I still have left to be able to bring it down to 44 millimeters? None. I'm going to need at least a couple of tenths of a millimeter to take out the saw cutting. I can't aim for 44, but let's aim for 43.5. This is also very useful to me for learning how much grinding allowance to leave. Let's first just rough this down until all the marks are out of it. Then I'll measure it again and then make a final decision of what height I'm aiming for. I know that's kind of cheating, but none of these dimensions are critical. I don't mind moving the goalposts because I'm not going to start a game with a different block of steel just to meet some fictitious dimensions. With that now cleaned up, I can go and measure it up and see where we're at, and then work out how much material to take off to reach a target dimension. 814. Nice. So I need to remove another 308 microns, but I need to do that using an imperial scale. And because I'm lazy, I'm going to calculate it. 0.303 divided by 25.4. So I need to take off 11th thou and 19th of a thou. So I need to take off 119 of these full graduations. Let's put a mark there where I start. This is the joy of having an imperial machine, but working in metric. I'm going to try and halve my distance to go. So after this one, when we measure, it should be 43.151-ish. What's the point of having an action cam if you don't put it in harm's way? You know, if I look at the amount of grindstone that falls off that wheel when I'm taking those heavy roughing passes at about 3 thou per pass, I really think I'm knocking diameter off the wheel quite a bit. Right, now we know what this should measure up to. It should be 43.615. However, I would not be surprised if it's larger, because I get the feeling that that grinding wheel is breaking down reasonably fast. So instead of 615, it's 696. I got a few of these grinding discs. The first couple were given to me by my mate Luke. So they're Norton discs. This 46 grit is clear to me. F, I think, is a reasonably soft binder. All I know is they seem to fall apart pretty quickly, but they stay nice and sharp. I couldn't find this TGP anywhere on the Norton website. 696. 694, 694. So I've got another 76 tenths to take off in imperial. You should be able to zero this dial by loosening off this ring, but unfortunately it's all gummed together. So I'll just have to count from here. From this one we want 76 more full steps. The magnet is tight, put's held down well. Right, in an ideal world, this is going to be bang on dimension, but I think it's going to be oversize. 76. Given both the surface finish and the amount of material that wheel is losing, it's not the right grindstone for this particular steel. But I really don't know enough about it yet to know what is the right sort. Oh, I just about did it. I just about walked over to the machine and dialed in another 76. But that's 76 microns, so of course I need 0.076 divided by 25.4. Need to take off another 29 10,000th of an inch. Make it 30. Did that next cut off camera. Still oversize. That wheel must really be losing a lot of diameter every cut. Right, so I've still got 14 microns to go, which is only another 5 10,000th of an inch. Must be getting close now. One of the coolest things about a surface grinder is there's no real minimum depth of cut, is there? So 2 over, you can sort of sneak up on these things with even almost at micron level. And bang on. Well, I'm a million light years away from Robin Renzetti's sort of sub-micron stuff, but here I'm 1 micron over. And spot on. That ends the section where I do it all using the hand wheels and reading off numbers. As you can see, you can definitely get pretty darn accurate. It just takes a bit of time and you've got to be careful not to make any mistakes with calculations. I think we'll see once I switch to using the DRO that it doesn't really change anything about this. It's just a bit easier and more convenient to get there. But that's just an assumption at this stage. So let's go and set this up. It's now Friday. I painted all this stuff on Tuesday. I guess they are now reasonably touch dry. It's certainly taken a while. It's pretty chilly here now, so I think what I might do is just throw all of these parts in the oven and give them a final hardening of the paint. The lucky thing is Mrs. RotarySMP is out, so I can throw these in the oven without her knowing. And because she never watches my videos, she's never gonna know. Yeah, you can still feel the paint's definitely pretty soft still. Ooh, looks like a nice beef stew tonight. Yum. So I reckon if I put all this stuff in the oven at maybe 70 degrees Celsius for an hour, I'm hoping that's enough to finish curing the paint. Mrs. Rotary really liked everybody's suggestion that we should get an induction cooktop because the oven's now died on our daughter's apartment. So now Mrs. Rotary's going to get a new oven and this one can go to our kids. Right, not my greatest paint job ever, but hey, most of this stuff's barely visible. There were some comments on the last video where people were surprised that I'm using slotted headed screws here, but these are existing holes and I think these are probably BA screws. They used to mount a lamp in this position, so you got to use what you got. Not my favorite sort of screw, that's for sure. Now I can start working on the display unit. So at this point, oh, there's a second layer on there too. So I've still got a wee bit of distortion there, but has pulled up these edges reasonably well. I used way too much glue stick to prepare the bed of the 3D printer when I made this part. It's got all these marks and stuff in it from the excessive glue stick. This joint on the end of the table here has to be sealed to keep the oil from dripping on the floor. Right, I need to adjust the slides to keep them running square to the travel. It's going to need a bit of adjustment. And now vertical alignment. Right, I'll just double check the alignment just to make sure it is actually vertical before I finally put in the bracket which drives the head reading unit. Okay, that's looking great. Well, it's within the tolerance limits, so I'm not going to do anything with it. I'll just mount the bracket and drive that head. Quick check. Okay, that axis is working. As is that. Right, with that done, I can now close up this access panel. Now, eagle-eyed viewers are going to notice that my current finished setup still leaves the power supply and the readout unit lying on the floor, but that's because I need to rewire the whole surface grinder, and those are going to find their space in the new control cabinet. Right, just make sure the whole machine still works. Another job finished. Okay, well that's the DRO installed and the guttering for the coolant system, which I haven't finished making up yet. So now I can do the second part of that accuracy test. So when we go and set this up for grinding these two ends, I've now got the issue that I need the vise to get my square across two sides, but I'm also going to have to put another block on the magnet to get my square in this direction at the same time. Right, magnet's held down nicely. Let's flatten off this first level, and here I get to turn on the DRO. We'll go and squareness check this. Check my zero again. Unfortunately, this indicator sticks a wee bit. Really should give it a service. This holder's got a beautiful fine adjustment on it. Really smooth to use. Okay, so this side I'm 2 100ths under. Flip it. And here I'm 2 100ths over. So on this axis, I'm about 1/10,000th of an inch under. And if I flip it, now I'm about 2/10,000th over. I'm a bit out of square on that axis. I guess I can try setting it back up in the vise again with my square block and just see if I can get it to sit better this time. Is that any better? Okay. And 1/10 over. Oh no, wait, a dash is 2/10, sorry, but this is 2/10. And that's bang on. I think I'll accept that as it is. Time to go and take this down to dimension. Now, will I still get 80 out of it? Kind of unlikely. If I can get it down to 80 millimeters, that'd be perfect. But if not, I'll clean up first and then decide what dimension I'm aiming for. Just put a bit of support behind it. Now I'll set down 1/10 of a millimeter for the next pass. Well, this is my first use of my DRO since I installed it, and I've just realized that my vertical scale is reading in the wrong direction, because I lowered it from 80.3 and I went down by 1/10 of a millimeter, but it counted up. So I need to go in there, scale 1. I guess I should be able to just go minus, huh? Sign change. Back. Back. So if I now go down, oh wait a minute, 0 it. If I go down, it goes down. Yeah, that's good. I'll just do a little touch-off pass again here because I'm nearly cleaned up. So it looks like I've got a reasonable shot at getting this to clean up by 80 millimeters. I'll do a touch-off pass, measure it, and then set the DRO. You know, I've just realized I don't even own a micron reading micrometer in this size. So we can see right here, we've got a gap in the accuracy of my measuring equipment. Up to 2 inches, I can measure down to a micron, whereas beyond 2 inches, I've only got micrometers with 10 micron resolution. Okay, maybe you can read off a quarter of that by sort of reading between the lines, but that already sets a limit on the accuracy of what I can do. Just check the setting of this. Okay, that's nicely zeroed. Okay, looks like I'm 11 over here. 80.11. 0.12, 0.11, let's say 0.105. So now I can tell it 80.105, and then we just grind down to 80. Did you notice that while grinding, the cross slide has very stable measurements? It quickly takes its position, there's very little bounce, there's no movement or anything, but the vertical axis seems to bounce around by about 3 microns, which, considering these are 1/10 micron scales, is about a 30 encoder click bounce, which seems a lot to me. I wonder if that's due to the way I mounted the slide using standoffs, whether it's just a bit too flexible, or whether it's because the read head is mounted directly onto the motor mount. Therefore, although the motor is rubber mounted, maybe there's some vibration coming through into that vertical casting that's being picked up by the scale. Okay, here we're still 3/100ths over. Here a bit more than 3/100ths. Yep, 3 100ths. And slightly more than 3 100ths. Okay, that means this number is 80.03 millimeters. And we'll try again at bringing it down to 0. That's measuring just a smidgen over 0. That's very slightly under 0. That's also very slightly under 0. So to summarize the initial question, does a DRO improve accuracy? The answer in German would be Jein, which is kind of a combination of yes and no. Accuracy is, to a large part, driven by skill and patience and workmanship of the person running the machines in combination with the quality of their tools. So the better tools you have, the more easily you can obtain any specific degree of accuracy. I'm pretty sure if you put Stefan Gotteswinter in a quarry with 3 pieces of stone, he'll also come out with a mirror fine enough to go fly on the James Webb Space Telescope. Where does the DRO fit into this? Well, it's another tool. It makes the process a little bit easier. It's probably going to reduce error by not having to constantly calculate distances to go and stuff to get down into your micron accuracy. If your tools are worn out, if your measuring tools aren't calibrated, if everything's of poor quality, if you're not patient, if you don't have the skill to have learnt a proper workflow of which order to do things, if you don't have good temperature control, all of these aspects, the DRO is not going to solve your problems and immediately start making micron level parts, which is a bummer because that's what I was hoping for. Now, another issue we've got is there are too many people out there doing fantastic technical projects who don't have YouTube channels. Luke and David, you know I'm talking to you. Just as an example of how you can get started on a YouTube channel, I recently was surfing the internet about Schauble and stuff, and I ran across Mitutoyo Shop. This must be a Canadian toolmaker who restored a Schauble 70, you know, one of the little watch lathes. His videos are a mix of video and slideshow with voiceover. Fantastic quality of workmanship. I mean, you've got to go and check this out. It's quite a small channel. I think he's only got like 600 subscribers today. And I guess for Luke and David and all of the rest of you out there who do amazing projects but aren't sharing them with us on YouTube, take a good look at what Mitutoyo's doing there, because much of his work is just slideshows with a bit of voiceover done after the project, and it's still fantastic. You know, if the project's good enough, you don't need that much editing. And I know you guys already take great photos of your projects, so please get stuck in. In 2026, we want to see regular machine videos from all you guys out there. So that's your homework for today. Jump over to Haxby's Shed, watch his mini video, watch all his Clarkson videos, comment and like and subscribe and all that. Give him some love, and then jump over to Mitutoyo Shop and blow up his channel, because I see he hasn't uploaded a video in about 4 months. So if we blow it up, maybe we can get him to do a whole bunch more videos, because obviously his machining quality is just outstanding. Got some great tips in there, so please go and help these guys out. My mate David called me up because he needs something ground. Now on the German Zerspannungsbody forum, he's Keilwinkel, and he's doing this restoration of a Belling und Lübke small cylindrical grinder. This is what it looked like when he first got it. The quality of his restoration is out of this world. At the moment, it's the cross slide he's working on, and I think he just wants to hog off a bit of material because it's not so easy to scrape between confined ways. So my friend David's come by again because he needs a bit of help with the surface grinder. Take a look at this. So what have we got?
So this is a part of my small cylindrical grinder, and the issue here is I can't get in here with the Biac scraper. I mean, I could, but it's very difficult. I would have to hand scrape it, and it takes a lot of time to do this. The arrow is not much, the numbers here, I don't know if you can read them. These are microns.
Okay.
So
the worst is about 100?
15 microns.
Yep.
And this surface has to be flat, of course, and parallel to the top side, which I already have scraped.
Wow.
I thought it is much more easier if we come in here with the surface grinder and make this parallel and flat. Only part that is left is here the dovetail, that there will be a step after grinding, and I will have to scrape this for sure. And only thing that should be left after grinding it on the surface grinder is to make some oil pockets.
Well, that's assuming, of course, that the surface grinder is accurate enough for your expectations. I think you'll probably find out that in the end you end up scraping the whole thing. I don't think I can get closer than about maybe 4 microns over the whole surface.
Even then it would be nice and would save me a lot of time.
Yep, cool. This is also cool that I've now got my DRO, because on the one hand it's metric, but on the other hand, because I put the DRO on the cross slide as well, it means we can keep within the boundaries without hitting the walls. So cool, let's move over to the grinder.
Hello YouTube. Mark is having dinner at the moment and he left me alone in his shop with his surface grinder. Time to get to know this machine and hopefully I don't destroy anything. I already dressed the wheel, found myself a dial indicator and adjusted my part so it is parallel. Now let's get grinding. Now I ground the first side and I didn't finish yet. I moved to the other side. I want to show you, it's very satisfying to see the scraping marks slowly disappear, and here on the edge there are still very deep scraping marks from the original scraping, and the tiny marks here in the middle that are my own scraping marks. Before I finish the side, I wanted to move over and bring the other side to the same height as this one.
Yeah, I'm not sure about this one.
Yeah, it's taken off everything nice and evenly, or you feel you got a good level out of it?
I will find out when I measure. What was your last measurement with the 5? I think you ground 5 washers.
Yeah, I want to say the worst was 4 microns low, about here.
Okay, that's not so much. Nothing to worry about. But I'm pretty happy because when I scrape this, the bluing up, the touching with the straight edge, I have to blue it 2 times because the part that matches with this is shorter. So I blew it up with a straight edge and I have to blue them up individually. And that means I always have to go back to my surface plate, measure the height of both sides and look if they are tilted and correct if they are tilted.
Right, yeah.
So this grind saves me a lot of time.
Some gauge blocks with you, what are they indicating?
This is the height of the way of the part that matches with this part. And of course, this surface should be the same height as the gauge block. And I have a small straight edge here. And this is a 0.3 millimeter feeler gauge.
Oh wow, so that really is a big gap.
Yes, it is.
Yeah. So we'll grind this down by the roughly 0.3. And then you'll shim it back up to give you the perfect feel, or do you want to try and nail it perfectly without?
I don't think that I will have to shim it. If it is too tight, I can scrape the underside of the matching part, or I can come to you with the gib and we grind a step in the gib.
Sure, yeah. True.
Way easier.
Yeah. So would you like to put it on the granite plate and measure the...
I will do that when I'm at home in my workshop. I will measure it and write down the deviation, and I will send you a photo of it.
Cool, thanks very much. Look forward to it.
Now, this is the result, and it's not so good as I expected. There's a difference of 9 microns, so I think we should rescrape your surface grinder mark. And the original scraping mark I didn't grind out here has an incredible depth of 30 microns. Maybe they scraped it with a hammer and chisel. Anyway, I'm very happy, and I'm sure this will save me some hours of pain. Thank you very much, Mark.
Well, I think that's another big step in usability of my surface grinder. Big thank you to Stefano at privado.com for providing a DrDro kit for me to assemble. I really appreciate it. What a great tool. Now, if you're enjoying this content, I'd appreciate if you'd hit the subscribe button and give me a little feedback. It's all very motivating and helps keep the channel running. And don't forget your homework. Get over there and check out Haxby's shed and also Metallum shed. I'll see you next time. Thanks for watching.